This is Enrique, and I'm going to explain to you the second workshop for this module of the class. This workshop is going to show you about Mininet and network topologies. There are four main objectives for this class. The first one is learn about network topologies. The following is learn about the basics of Mininet, which is going to be briefly explained later. You're going to learn about OpenFlow, that is an SDN protocol that is going to be really interesting to us to learn about how you can implement SDNs in the real world. And finally, we're going to learn how to do measurements on networks to learn about the rules that you implemented and additionally the topologies that underlie these rules. First, let's talk about what is Mininet. Mininet is a network emulator that is able to run kernel, switch, and application code on a single machine for each of the elements of your topology. Each of the hosts is going to be running a standard Linux network stack, actually the whole Linux stack, such that you can run any type of code unmodified. So that's for the controller, for the host, and for the switches. As we mentioned before, we are interested in working with OpenFlow protocol, so the switches that Mininet supports can use this protocol. One of the main interesting things about Mininet is that it is interactive. So once you start Mininet, he's going to spawn the topology, he's going to spawn the host and the code that is running on there, the controller and the switches, and then you can start modifying the topology using a command line interface and run additional commands on each of the hosts, controller, and switches. So as I mentioned before, OpenFlow is an open standard for software-defined networks. As we explained during the class presentations, we're going to be separating the control and the data plane. The data plane resides in the switches, while high-level routing decisions are moved to a separate controller. It's normally typically a server, and then these decisions are called the control plane. So the data path of an OpenFlow switch presents a clean flow table abstraction. So each entry in the table defines packet fields to match and an action to be performed. So we can see this in the image we have here. So we have a rule. Basically, we could be either matching IPs, we could be matching MAC addresses, the Ethernet type of packets that are being sent. And then we define what are we going to be doing with those packets. And then we're going to be deciding what actions we're going to have for those rules. Each of the entries are going to be installed on the switches by the controller. So the controllers and switches communicate using the OpenFlow protocol. For this workshop, we're going to focus on implementing a network topology so you learn how to use Mininet. This topology is the one shown here, in which we have three levels. The first level are the hosts. These are the ones that are going to be executing your code and are the ones that are going to be using the network topology. Then we have the edges that are in green, and basically this is the layer that is connected to each of the hosts. And then we have the cores that are the ones in orange, and these are the ones that are going to be connecting the switches. We can notice here that we can have multiple paths from going from one host to another one. For example, if we have H1 and we want to go to H3, we can go through E1, then C1, then E2, and then H3. But another possibility could be, okay, again we can go through E1, but then we choose C2, and then we choose E2, and then we go to H3. So our controller needs to be able to handle these multiple paths between hosts. For the topology that you're going to be implementing, there are going to be 4 parameters that you need to take care. So the topology can be used in multiple sizes. For example, we need to be able to define the number of cores that we're going to have, in which all the cores are connected to all the edges underneath. We have the number of hosts per edges. For example, in this case, we have 2 hosts connected for each edge. And additionally, we're going to be defining the bandwidth. To make this workshop simple, we only want to have one type of bandwidth for the whole workshop. The first step is to download the virtual machine and the Git repository that is going to give you the base code for developing this workshop. From the repository, you're already going to have the controller fully implemented. The only file that you need to modify is the mininet topology.py. This is going to be the one that is going to be implementing the mininet topology. To be able to complete the file that I just mentioned, you're going to be using three main APIs. The first one is the add switch. This basically tells to Mininet to create a switch with a given name and using a specific protocol. For our case, we're going to be using OpenFlow 1.3. So that's the reason why we have this OpenFlow 13. Then you need to be able to create links between the different elements in the system. First, we need to create a dictionary that defines the main characteristics of these links. So it's going to have bandwidth, it's going to be the delay from the source to the destination. We have the maximum queue size that in most of our scenarios is going to be 0. If we want to have certain kind of flows properties on the link, and these are the main components that you need to know. Then when we want to create an additional link, we just use the names that we created before, such as here, when we create the switch, we have the name of the source, the name of the destination, and then we just append the configuration file that we created on the previous step. Additionally, we need to create the hosts. And the host is really simple. You just use this add host, and additionally, you show the name of the host. And this is the name that you're going to be using when adding links here. To run the code, you first need to run the Mininet code. This is just a simple Python script, so you can run it directly using sudo. So you have privileges, the Python interpreter, and then the file that you just completed on the previous section. Then you need to run the controller. We are going to be using Ryu. That is an open source Python implementation of an OpenFlow controller. We will discuss in more detail in the further workshops, but for now, you just need to learn how to start this controller. First, we need to run the Ryu manager. There is an application that is included in the code of the Ryu controller. We use verbose to see everything that is happening in the controller, and then we just show the path to the controller that we want to run. In the description PDF, you're going to see a much detail on where are these files located and how to copy those in the corresponding locations. Once everything is running, then we just have the Mininet commands. We're going to have this command that is nodes, and that's going to show us all the nodes that have been created in the topology. Additionally, we have links that is going to show us all the links and how the nodes are connected between each other. So for this class, we're going to be using software switches. More specifically, we're going to be running OpenVSwitch code. That is an open source software switch implementation that complies with the OpenFlow protocol. As we can see here, this OBS is the meaning of OpenVSwitch, and here this defines one of the commands that we're going to be running on this OpenVSwitch. This specific command is going to show us all the switches that are available in the system and some really general characteristics of the switches that we're deploying. Then, if we want more information about each of the switches, then we can run this command. This command, you just need to assign the switch name that you created on the previous steps, and remember to use the protocol flag such that it knows how to talk to that switch and get the corresponding information. Finally, we're going to test the topology. We're going to be testing both bandwidth and latency. To be able to test bandwidth, Mininet has its own wrapper around the iperf command. iperf allows us to define a certain amount of data that is going to be flowing between the source and destination. In the Mininet command line interface, you're going to be running iperf, and the host 1, that is the source, and the host 2, that is going to be the destination. This is going to try to return to you the max allowed bandwidth that you can use to communicate between the host 1 to the host 2. Then, if you want to check if there is reachability between all the hosts available, then we can use ping all. This is going to be starting to send messages from all the hosts to all the hosts to see if we can actually send information from one to the other one. Finally, Mininet allows us to be more specific between the host to which we want to do the ping. So we define the host 1, that's the source. We use ping to contact host 2. Additionally, this is going to return us the information about the latency between host 1 and host 2, and this is going to be running repeatedly. You need to stop this using Control-C such that you don't get stuck in a while loop with the host 1 sending ping messages to the host. And this is the main components of the workshop 2. You already learned about how to implement topologies using Mininet, how to check that everything was correctly set up, and finally testing bandwidth and latency.